Good morning, guys. Last class we have studied about the computer system architecture, right? So here there are three types. One is a single processor system, multiple processor system, and clustered system. So first of all, what is a processor? So processor is an integrated circuit that performs a mathematical calculations and logical operations. Okay, so you just type it in a Google so that you will get to know what is a processor. Okay, so based on that processor, how the system will be designed. So in a single processor system, I already explained about the single processor system. So it performs all the activities by the single processor. Here only one general processor will be there, and some other special purpose processors will also be there. But general purpose only one processor will be there. Okay. So next we will move on to the multi-processor system. So second one in the computer system architecture or a design. So architecture means it's a design of a computer system. So here the design of a computer system means first one is single processor. So single processor means only one general purpose processor will be there. So it will take care of everything. Okay. So only that processor will do all the work. So in the next one, multi-processor system. So in the multi-processor system, so here more than one processor will be there. More than one processor will be there. So or you can say the some systems have two or more processors will be there. So these systems are in a parallel systems. So like this. So this is a one processor and here is another processor in the same integrated chip or a IC. Okay, so in the same IC here like this parallel processors will be designed, but these two will share the same bus. Okay, so bus means it's an electronic path. Okay, so the common system bus will be shared by these two processors. This is one processor and this is another processor. So but in the single processor system, only in an integrated chip, only one processor will be there. Okay, so this is the difference between single processor and multi-processor. Okay, so here two or more than two processors will be there. Okay, so general purpose processors, these processors will be parallelly, it is designed in a integrated chip. Okay, so mostly processors of these system share the bus. Okay, so that is common system bus, and these will also be called as a tightly coupled systems. Okay, so here the memory and input output devices, all these will be shared by these two processors, and the systems are very fast here because two processors are there. Okay, so here if ever so many tasks are there, so these two will be shared the task. Okay, so that is the reason these two, that is multiprocessor systems, are very fast. Okay, so again it can be further divided into two types. One is asymmetric multiprocessing system and another one is, so this multiprocessor again it will be divided into two types. One is asymmetric multiprocessing system, asymmetric multiprocessing system, and another one is symmetric multiprocessing system. Okay, so now what's the difference between these two? Asymmetric means what is asymmetric and what is a symmetric means. So here in the asymmetric, in in this one that is asymmetric multiprocessor means here more than one processor will be there. Okay, so in this one again there are two types. One is asymmetric and symmetric. In asymmetric, each processor is assigned a specific task. Okay, so how many processors will be there? For all these processors, some specific task will be assigned. Is known as an asymmetric multiprocessing system. Okay, so that is each processor in this one each processor is assigned a specific task. Okay, so this is called as asymmetric multiprocessing system. So here each processor is assigned a specific task. Okay, so here like a master and slave relationship will be there. Okay, so one processor master slave relationship will be there. So here any one processor will be taken as a master and others are a slave. The master processor, so if ever we will take it as like this, so many processors will be there. So now this one will be taken as a master, and here these are all slaves. Okay, so whatever master processor will be there, so this will control all these processors. Okay, so these master processor will be control all the other slave processors, and it executes predefined tasks. The master processor controls the system, and other processor execute predefined tasks. That means already whatever assigned to these processor, that will be done. Okay, so the master processor also defines the task of slave processors. Whatever the master processor is there, this will define whatever the master processor it will controls, and then it will defines the task whatever given to these slave processors. Okay, so now next is a symmetric. In the symmetric, each processor performs all types of, so here in the symmetric, each processor performs all types of task within the operating system. Okay, so here each processor performs all types of a task. Here there is no master slave relationship. Okay, so many programs can run simultaneously, that means one after another. Okay, so here each processor performs all types of a task and it's not like a master and slave. So here all the processors will do all the work. Okay, so this is the difference between symmetric and asymmetric. Now, what are the advantages of multiprocessor system? Until now we know about what is a multiprocessor systems, right? So multiple processors are designed in a integrated chip. Okay, so that is just like a parallel processors. Okay, now within this, so now what are the advantages of multiprocessor system? So everybody knows here, since we are having a more than one processor, so here time taken will, so are the number of processors executed by the CPU at a given time is higher or more. Okay, so this is one of the advantage, that is number of process executed by the CPU at a given time. So for example, 2 seconds will be there. So within that time, how many tasks will be executed by the CPU? Okay, so that will be, obviously it is more only because of so many number of processors. Since it is a multiprocessor, so this, whatever the number of processes executed at a given time is called throughput. Throughput is more because of multiple processors. So next one, cost. So cost is, compared to single processor, it's a less only, because so if the single processor means all the input output or else whatever the other things that will be connected to the system is that is attached to only to that system. Because of that, so here the single processors are more costlier, and here since whatever the processors here it is there, so these processors will share the same peripherals. Okay, so same resources will be shared by these processors. That is the reason here the cost of this multiprocessor systems are less. And here reliability will also be increased. Here increased reliability. Increased reliability, what is this? If any one of the processor fails, okay, so it won't halt the system, but so other processors will take that job and they will complete, but the speed will be little bit less. Speed will be slowed down. Okay, so here number of processors executed by the CPU at a given time is a higher or more, that is throughput is more, cost is less when compared to single processor, and here the increased reliability. That means any one of the processor will be failed, so it won't halt the system. Instead of that, other processors will take that task also and they will execute that one, but the speed will be little bit less. Okay, so now this finished, right? So whatever the that is a computer system architecture, and then Here the advantages of multiprocessor systems. Next is next one is clustered system. So here we have seen single processor system. Here we have seen the single processor system and multiple processor system, and now the clustered system. What is this cluster means? Cluster, everybody know what cluster means. It's a group. Okay, so that is a group of systems will be connected through a LAN. Okay, so here the systems also contains the multiple processors, but it differs from a multiprocessor system. Okay, so multiple processors will be connected, but it is different from multiprocessor system. So the clustered system is composed of multiple individual systems. See, previously I showed that. See, in a multiprocessor system, in a single integrated chip, so the processors will be decided. But in the clustered system, it's not like this. It's a individual systems. Okay, so individual systems will be connected. Okay, so as a cluster, individual systems are connected. How it will be connected? How those individual systems will be connected means that is through the LAN. Okay, so local area network. Here also same thing. So if any one of the system like this, see, so this is one system and this is another system like this, all these will be connected through the net, that is a LAN. Through the LAN it will be connected, and here if any one of the system will be failed, okay, so rest of other systems will be worked. Got it? So this is the clustered systems. Now the next topic is view of operating system. What is a view of operating system? So in what way we have to assume, that means on what basis we have to design the operating system. So there are two ways. One is two views. So one is user view. According to user, we have to think and we need to design. Okay, so according to the user view. Okay, so if the user is using, so the user's view of the operating system depends on type of the user. So what type of user it is. Okay, so here if ever the user is using standalone system. Standalone system means, so each and every application program or anything whatever you want, so everything will be in a single system itself. Okay, so that is called a standalone system. So it won't depend on other systems. Okay, so for any resources or anything, so it won't depend on another system. This is called the standalone system. Okay, so if ever the user is using the standalone system, then the operating system is designed for the use and high performances. Okay, so why it should have a high performance? Because each and every application program or whatever the user is using, so all the things will be there in a single system itself. Okay, so that is the reason if the system has to manage all these things, so it should have some high performances. Okay, so that's the reason according to the standalone system the operating system has to be designed. And the next, if the user are at a different terminals means are at different places or at different nodes. Okay, So then it should be connected to a mainframe or a microcomputers, okay, by sharing the information and resources. The operating system is designed to maximize the resources, okay. So if the users are at a different places, okay, so any one of the server will be there, and here is a one node, here is one node, and here. So here whatever the terminals are there, all these terminals are sharing this server, okay. So that is why it has to maximize the resources. Got it? So next one, if the user are in a workstations means that is for that is used for professionals or engineers will be used like that, okay. So if the users are in a workstations connected to networks and a servers, then the user have a system unit of their own and shares resources and files with other systems, okay. And then here the operating system is designed for both easy of use and also resource availability. So here easy of use, and here resource, that is a resource, here it should be maximize the resources, and here this is the different terminals if ever the user is at a different terminals, and here if ever user is at a workstations, it should be designed, it should be easy of use, and also it should be the maximize the resources, okay. And another systems like embedded systems will be there. Embedded systems are just like a AC, washing machine. So these are the embedded systems, okay, used in a home devices. And automobiles do not have any user interaction. It should not have any interaction. It should do by itself, okay. And then users of a handheld system, okay. So here handheld system like expects the operating system to be designed easy of use and performance should be more, okay. So this is the user view, and another one is second one is the system view. System view, okay. In a system view, so system if we will see according to the system, so what are the things it will be required while designing the operating system? So they should, that is resource allocator. What actually the operating system will do means, here it will allocate the resources whichever the processor requires, correct. And also it will control the program, okay. So according to the system view, so resource, it should be a resource allocator, a good resource allocator, like files or else any input output device or memory, anything, okay. So it should make the availability of resources to the processor, okay. So according to the system view, it should be resource allocator. And another one is it should control the program or manage the execution of a user program to prevent some errors and improper use of the computer, okay. You should show some notifications, okay. So that means control the program, okay. So this is the view of the operating system. So there are two views. First one is a user view and another one is a system view. So in a user view, if ever is a user is at the standalone system, it should be easy of a use. And if the user is using at a different terminals, it should maximize the resources. And here if is the working at the workstations, then it should be easy of use and also maximize the resources. And the embedded system is, so here human interaction won't be there. Okay, so it should do by itself. That means performance should be, it should be nice or more. So according to system view, it should be the resource allocator, and here it should control the program. So whichever the resources, it can be a time or a memory, space, file storage, space, input output devices, or files, anything. Okay, these are the resources, and that should be available to the processor. Okay, and then it should control the program. So next one is the parts of the operating system. So here there are two parts of the operating system. First one is a kernel and shell. Okay, so here the kernel is a core of the operating system. Okay, so it's a innermost layer of operating system. It controls the computer resources. Okay, so this one will be controls the resources, and it will allot to the different users who has requested, and it interacts directly with the hardware. Okay, so whatever this kernel is there, so this will interacts directly with the hardware. Okay, not with the user. It won't directly interacts with the user, but it will interacts with the hardware. So here user will request for anything, and here the shell will be there. Okay, so shell is another part. Okay, so first we will see this kernel. Kernel is a core of the operating system. Okay, it's a kernel is core of the operating system. It's a core of the operating system, and the inner, we will say it's a innermost, inner layer of operating system. What it will do, it controls the computer resources. Allotting them to the different users and different tasks. It interacts directly with the hardware. Interacts directly with the hardware. Okay, so kernel is the part of the operating system that loads first. Okay, so it will load first, and it remains in a main memory. It handles the input output request from a software and translating them into a data processing instructions. Okay, so for the central processing or CPU, for CPU. So next part is shell. So here we know about this kernel. Right now we should know about shell. What is a shell? So shell is we can say it's an interpreter for the kernel, and it is the interface between the user and the kernel. Okay, so here user and the kernel, it's an interface between user and the kernel. Okay, so shell handles user interactions by prompting the user to give an input. Okay, it will say to the user to give an input, and then that will be interpreting the input for the operating system, and then it will handle the output from the operating system. Okay, so first whatever the user makes the request to the operating system, so that should be through the shell. Okay, so it should be through the shell. First, shell will check in the user's request. Okay, so here user makes a request here. Makes a request to the operating system through which one? Through the shell. Through the shell. And then what the shell will do? Shell will check those requests. Checks users requests for validity and correctness. If it is not correct and if it is not a valid input, then it will send back some information to the user to give a proper input. Okay, so if ever it is a correct and valid input, then that will be passes to the kernel and then passes it to the kernel. And what kernel will do? So after getting this request, that is whatever the user makes a request, so that will be received by the kernel, and it will check whether those hardwares are free or not. So if ever that hardware is free, so these will be assigned to the processors. Okay, so processors will do the job whatever the user is requested. So that again, so if they have done the job, once it will be done, so that will be reported to the kernel, and then kernel will send it to the shell, and then shell will send it to the user. Okay, so this is the procedure. So how the operating system will work. Okay, so these are the two parts of operating system. So kernel and shell. So kernel is the innermost layer of the operating system and shell is the outer layer. Okay, so shell is it's an interpreter between